Our next topic is Bernoulli equations. A Bernoulli differential equation has the form dy by dx plus y p of x equals y power n q of x. So the difference between the linear and the Bernoulli is this term over here, y power n. And this is the standard form. Remember that this is the standard form. So that's the form we are going to use. If again, just like the linear equation, we will divide anything which is appearing over here, any constant, any function. We must divide that first, and then we will decide about p of x and q of x. So the substitution for this one is so if we have a Bernoulli equation, then the substitution y equals u power 1 over 1 minus n. U is a function of x, once again, and n is a number which is coming from here. This is the n we use here, and u is a function of x. It is unknown to us, but function of x. The substitution will convert Bernoulli equation, Bernoulli as well, some people say Bernoulli differential equation into linear differential equation in variables, linear differential equation in variable u. Then once it is linear, we can repeat the method of linear differential equation, which was integrating factor and all that, and we can solve it. So let's see a simple case. Question number 15, same exercise. Solve the differential equation using as you can see, the question does not tell you which type of substitution or which substitution. It says appropriate substitution. So we have to remember that which one is which. Okay? So this one is x dy by dx plus y equals 1 over y square. What is our first step? Divide by x. Remember that you have to write the standard form. Okay? Nothing could be multiplied with dy by dx. I'll write this in the form 1 over x y power minus 2, so that we can say that n equals minus 2 with comparison to our standard form. Okay? So y power n. So we have the form. Our p of x is 1 over x here. Our p of x is 1 over x. But no need to write yet. Let's first convert it into linear, then we will write the p of x. For now, n is enough for us because we are going to use this in the substitution. Y equals u power 1 minus 1 over minus 2 here, and that implies y equals u power 1 over 3. Right? Now, as I said earlier, because we are going to replace y with u power 1 over 3 here, and then we must replace dy by dx as well. Okay? What is dy by dx for this function? 1 by 3 power rule, 1 by 3 minus 1 into du by dx chain rule. Okay? It's just like if you had y equals, let me take sine x again, sine x power 1 by 3. What would be the derivative? 1 by 3 sine x power 1 by 3 minus 1 into cosine x. What is cosine x here? Cosine x is derivative of sine x. Okay? Is that right? That is why we write du by dx, because u is a function of x, although it is unknown, so we must write the derivative of u, completing the chain rule. Alright, let's put the value of y and dy by dx into the equation. That will give this side dy by dx. Here dy by dx will be replaced by this thing, okay? 1 by 3 u power, well, we can write 1 by 3 u power minus 2 by 3 du by dx. So u power minus 2 by 3 du by dx plus 1 over x y, and y is now u power 1 by 3. Okay? Y is u power 1 by 3 equals 1 over x y power minus 2. So u power 1 by 3 whole power minus 2. Let's look at this again. This is dy by dx. This thing here is y, and this is y power minus 2. Okay? dy by dx, dy by dx plus 1 over x, no change. Y is u power 1 by 3 equals 1 over x, no change. Y power minus 2. This is y power minus 2. Now we have to simplify this a little bit. The only simplification in this step is this power. You can multiply it inside using algebra rule. A power m whole power n, a power n multiply n. Second important step is, okay, I'll write it again, 1 by 3 u power minus 2 by 3 du by dx plus 1 over x u power 1 by 3, 1 over x u power minus 2 by 3. Now we will divide by this thing. Divide. So that there is nothing attached with du by dx. If you remember, the standard linear form for the linear equation looks like, how does that look like? Du by dx plus p of x u equals q of x. So nothing should be attached to du by dx. So we divide du by dx plus 1 over x u power 1 by 3 over 1 by 3 u power minus 2 by 3 equals 1 over x over 1 by 3 u power minus 2. Now this 1 by 3 is like 1 over 1 over 3, which means 1 divided by 1 over 3, which means 1 multiplied 3 over 1. So this is actually 3. Okay? And what about this area here? What do we do with these two? This one. We have to bring u up and add the power. Okay? Again, using a power m over a power n, a power m minus n. Or if it is already negative, let's say it is negative, then it will become plus when I comes up. So this is equal to du by dx plus 1 over x u power 1 by 3 plus 2 by 3 1 over x. This one, yeah, this 3, of course, 3 I forgot, this 3 and this 3. These two will cancel out because same power, u power minus 2 by 3, u power minus 2 by 3, so we get only 3 by x. What is this thing? Du, let's keep the red color black, du by dx plus 3 by x u equals 3 by x. Very clearly it is linear in u plus 3 by x outside. P of x u equals q of x. Okay, so now we find if e power integral 3 by x dx equals e power 3 log of x e power log of x cube and x. We multiply this equation. I'll name it number 2. I'll name this one as number 1. Right, multiply number 2 with if, which will give du by dx x cube times 3 over xu x cube times 3 over x. That is du by dx and x cube plus 3x square u equals 3x square. Our method says that at this point it should be the dependent variable, which is u, times the if, which is x cube. And now we integrate u times x cube by 3 will cancel, plus c. What is u here? Y equals u power minus, what was that? U power plus 1 by 3. U power plus 1 by 3. So what does this mean? U equals what? Take 3 power on both sides, cube and cube, and that means u equals y cube. So this becomes x cube, y cube, x cube plus c. If you want, you can divide by x cube just for right. So there are 2 questions in one. Actually, it's a little lengthy question. In the first part of the question, we divide by x to make the standard form and then use this minus 2 here as an n to construct a substitution. Then we take the derivative using chain rule, put the derivative and the value of y in these 3 locations, here, here and here. Dy by dx, y and y power minus 2. This is dy by dx, y and y power minus 2. After simplification of this one step, we divide whatever we have with du by dx, the whole thing, both of them, okay, just in one step. You can do them in 2 steps, like multiply by 3 and then divide by this, so it will get the same answer. And then simplify. this side will always cancel. Yeah, that is also a hint for us that we are on the right track. Okay? This side will always cancel, and this term will always give you u power 1 here, always, so that this new equation becomes linear in u. Okay? This one linear in u. Okay? And then we follow the method for the linear equations. We find if using this p of x, and if, this is our p of x, okay? Linear in u with, so in our equation p of x is 3 over x, and we multiply the equation with p of x, if, left hand side becomes this derivative, and then we integrate. Right, if we remember the steps, then the solution is not very difficult actually. Okay, let's start another. T square dy by dt y square equals ty. What is the standard form of Bernoulli again? We can see that there is a y square here, so it is Bernoulli, but it should be on the right hand side, not on the left hand side. That will not work if we continue keeping it here at this position. We have to move it we have to move it here. Y square should be on the right hand side. The standard form says dy by dt p of x y equals q of x y power n. So it should be on the right hand side. What do we do? The first step is t square dy by dt plus, not plus, minus ty equals minus y square. And then we divide by t square minus 1 over t y equals minus 1 over t square y square. In this step we have divide by t square. Now we have our n is 2. This implies our substitution equals y equals u over u power 1 over 1 minus n, which implies y equals u power minus 1. Alright, now we take the derivative. Dy by dt, remember that our independent variable is t this time, not x, minus u power minus 2 du by dt. Now we put these two values into the equation, minus u power minus u or minus 2 minus 1 over t u power minus 1 minus 1 over t square u power minus 1 whole square. Okay, I'll call this one equation 1, and I'll write here, put dy by dt and y in 1. Okay, right, I'm going to directly divide this. We'll simplify with this part in the same step, du by dt, or I'll record the step here, du by dt minus 1 over t u power minus 1 over minus u power minus 2 equals 1 over t square u power minus 2. This minus 1 and multiply 2 over minus. Right, du by dt minus, well, minus becomes plus because of this minus. This minus 1 plus 2, minus 2 goes up and become plus, equals 1 over t square, and this again u minus 2 cut, and this minus will make plus, and this implies du by dt plus 1 over tu 1 over t square. As I mentioned earlier, that this will always become u, and u will cancel on this side, on the right side, and always you will get a standard form in du by dt plus p of tu equals q of t. So your p of t here is 1 over t. Okay. The rest is exactly like linear. I'll leave it for you to complete. Complete as homework. Rather, homework is an official word for homework, so I'll write complete at home.